Hi, this is Ganesh Krishna, and I qualified my MSc Organic Chemistry. Now, this is my first video that is in the online section. Let me start with the concentration definition in concentration terms. Here, what is meant by concentration? Concentration is defined as it is the amount of solute present in given amount of solvent or solution is known as concentration. Okay, right. So here, if you go with the example to understand this, let me take the example of here. Coffee were taken as an example because it is our day-to-day life substance which we used to take in generally. So we used to listen strong coffee and light coffee, which in generally people used to ask. A strong coffee indicates that it is having more amount of coffee powder, and light coffee indicates it is having less amount of coffee powder. Where in both the cases the amount of milk is the same, but amount of coffee powder is more in strong coffee and it is less in light coffee, which indicates that strong coffee contains more amount of solute, that is coffee powder, which is treated as concentrated solution according to chemistry, and the light coffee consisting of less amount of coffee powder, which can be treated as a diluted or less concentrated solution, which is having less amount of solute, that is in the form of coffee powder, within a given amount of milk. Okay, so this can be helpful to you to understand the definition clearly. Right. Now here, if you come across what are the different types of concentration terms, involved, to find out the amount of solute. Here there are two ways of measuring the concentration terms. One is a physical method and the other one is a chemical method. Here in physical method we can see that we are going to find out the amount of solute in terms of weight, whereas in chemical method we are going to find out the number of solute particles in a given amount of solvent or solution. So what are the concentration terms involved under this, and what are the concentration terms involved under this? Let us discuss. Here under the physical method we can see weight by weight percentage, volume by volume percentage, weight by volume percentage, and volume by weight percentage. And the second one is parts per million, represented as ppm. Third one is parts per billion, represented as ppb. And the fourth one is a strength of a solution. Right. And under the chemical methods we can see molarity, which is widely or extensively used concentration term. And the second one is molality. Here molality is represented by small m, molarity with the capital M. Okay. And the third one you can see normality, represented with the capital N. And the fourth one is mole fraction, represented by X. Okay, so these are the concentration terms involved in the physical method. and these are the concentration terms comes under the chemical method. Okay, now let us discuss in detail about these concentration terms. Here right. Here let us discuss about the first one, that is weight by weight percentage. What is meant by weight by weight percentage? Concentration term. It indicates that in this concentration term we are going to measure the. It is a measure of. It is a measure of amount of solute measured in grams, amount of solute measured in grams, present in 100 grams of solution is known as 100 grams of solution is known as weight by weight percentage. And what is the mathematical representation to calculate the weight by weight percentage is given as weight of solute by weight of solute plus weight of solvent in the numerator into 100. Okay, right. And here, if you come across the weight of solute plus weight of solvent can be taken as the weight of the solution. Okay, right. Here, units of weight by weight percentage do not have any units. Why they do not have any units means because it is a ratio of two similar physical quantities, that is weight terms, which are measured in same units, that is grams and grams, which is cancelled. Okay, and the other characteristic feature here, this concentration term, that is the weight by weight percentage, does not gets affected by change in temperature. Does not get affected by change in temperature. Does not get affected by change in temperature. Okay, and here let us go with the second concentration term. The second concentration term is volume by volume percentage. What is meant by volume percentage? Here it is defined as it is a measure of amount of solute measured in milliliters, present in 100 ml of solution, of solution is known as volume by volume percentage. Okay, and here what is the mathematical expression to find out the volume by volume percentage? It is given by volume of solute into 100 by volume of solute plus volume of solvent, where volume of solute plus volume of solvent can be taken as the volume of the solution. Right. Later, do this volume by volume percentage, do they have any units? Even volume by volume percentage also do not have any units. It also do not have any units. But this volume by volume percentage is going to get affected by the change in temperature. The reason is due to change in temperature, volume of the substance gets affected. Due to that, volume by volume percentage gets changes. Volume by volume percentage do not have any units, similar to weight by weight percentage. And volume by volume percentage concentration term gets affected by change in temperature, because with the increase of temperature, volume of the solution gets expands automatically, or volume by volume percentage is going to get decreases, because volume of solution is inversely proportional to volume by volume percentage. As the volume of a solution is a bigger value compared to volume of solute, if this value changes to much extent, automatically this concentration term also gets changes. Okay, right. Next concentration term. What is the next concentration term? Third one is you can see this third one is weight by volume percentage. So what is meant by weight by volume percentage? Weight by volume percentage, it is defined as, it is a measure. It is a measure of amount of solute measured in grams present in 100 ml of solution. Present in 100 ml of solution is known as weight by volume percentage. Okay, right. And what is the mathematical expression used to find out this weight by volume percentage? Let me show you that. Here, the mathematical expression that can be used to find out the weight by volume percentage is given as weight by volume percentage is equal to weight of solute, which is measured in grams, by volume of a solution, which is given in ml. In the numerator, multiplied with 100. Okay, right. Now, what is the unit of this concentration? Weight by volume percentage unit is gram per milliliter. Gram. Solute measured in gram, solution volume measured in ml. Right. Next, do this gets affected by the temperature? Yes. Weight by volume percentage gets affected by temperature. Why it gets affected by temperature? Because in this mathematical expression, you can see volume term is there, where volume is going to gets affected with the change in temperature. Okay, whereas weight will not get changes with the increase or decrease of temperature, but volume of the substance gets expands or contracts with the increase or decrease of temperature, where automatically when this gets changes, automatically this total value gets changed, and the weight by volume percentage gets changes. Okay, right. So this is the third concentration term, that is weight by volume percentage. And if you come to see the fourth concentration term, that is our volume by weight percentage. So that concentration term, in generally, practically it is not used. So even in our exams also we used to not get the questions based on this volume by weight percentage. Okay. So let me give the relation between here next thing is a relation between weight by weight percentage and weight by volume percentage. What is the relation present between weight by weight percentage and weight by volume percentage? Here, weight by volume percentage is equal to weight by weight percentage into density of solution. This is the relation. So you can understand even this by expanding this here. Weight by weight percentage written as what? Weight of solute by weight of solution into 100. Density of solution can be written as weight of solution by volume of solution, where we know density is equal to mass by volume. Mass is nothing, but here we can take weight. So weight of solution gets cancelled, then we will get weight of solute into 100 by volume of the solution. Okay, right. So this is a relation between weight by volume percentage and weight by weight percentage, right? So later, let us get into the next concentration term. that is parts per million, parts per million, which is generally known as ppm. Right. What is the definition of a parts per million? Parts per million is defined as number of parts of solute, nothing but solute measured in grams or milliliters, present in 1 million. 1 million means 10 to 6 parts of solution. Is known as parts per million. Right? And what is the mathematical expression given to this? Is parts per million is calculated as number of parts of solute, nothing but we can take it as weight of the solute by number of parts of solution, nothing but weight of the solution, or volume of the solute by volume of the solution, okay, into 10 power 6. Okay, so this is the mathematical expression to find out the parts per million. And what is the importance of this concentration term is, this concentration term is used when solute is present in traces. Traces means nothing but very small amount. Okay, that is the meaning, right? And what is the unit of this parts per million? Unit is ppm. ppm itself, it is taken as unit for parts per million. So similarly as parts per million, so we are having another concentration term that is called as parts per billion. So what is the difference between parts per million and parts per billion is, here instead of CL million, we will be going to take it as a billion, and the definition will be written as number of parts of solute present in 1 billion parts. 1 billion instead of million. 1 billion means it is equal to 100 crores, which is written as 10 power 9. Okay, 1 billion parts of solution is known as parts per billion. Okay, and here the formula will be written as parts per billion is equal to number of parts of solute by number of parts of solution into 10 power 9. Here even these parts per billion also can be used when the solute is present in traces, and the unit of the parts per billion is a ppb. And see here, in generally among parts per million and parts per billion, parts per billion and million, okay, in generally parts per million will be used to much extent compared to the parts per million. Okay, and whenever water which is contaminated with bacteria or any other microorganisms, there the amount of bacteria that is present in water is in generally, it is measured by using which concentration term is in generally by parts per million. Even the fluorinated water, okay, which causes a disease called as a fluorosis. So even the amount of fluorine present in a given water is also measured in terms of the concentration of ppm. Whereas if you observe the weight by weight percentage, the weight by volume percentage, and volume by volume percentage, these concentration terms are in generally used in medical industries, that is on the ointments and even on the tonics. Okay, you can see the composition of the medicine present in that, okay, as in the form of weight by weight percentage or weight by volume percentage. Like this, there the composition will be mentioned on the medicine. Okay, right? Let us go with the, instead of parts per billion, let us go with the next concentration term, that is the strength of the solution. Okay, so what is meant by a strength of solution? Strength of solution is defined as, number of grams of solute. Number of grams of solute present in 1 liter of solution. Number of grams of solute present in 1 liter of the solution is called as strength of solution. Okay, so strength of solution is given as the definition is given as number of grams of solute present in 1 liter of a solution. 1 liter of a solution is known as strength of solution. Is known as the strength of solution. Okay, and what is the mathematical expression to find out the strength of solution? Here, strength of solution is given in the formula as weight of solute by volume of solution. Okay, and unit of strength of solution. What is the unit of strength of solution? Strength of solution unit is given as gram per liter. Okay, so these are the total concentration terms which comes under the physical methods. Okay, where in all these concentration terms we are going to measure the amount of solute that is measured either in grams or in milliliters, where that can be physically weighed by using weighing balances, but we cannot able to find out the number of particles by these concentration terms, where these concentration terms are called as the physical method of concentration terms. And coming to the next thing, that is the chemical way of measuring the concentration terms. So chemical method of measuring the concentration terms. So already we given you some headings under the chemical method of concentration terms. What are these? Let us discuss. Here, molarity given with the symbol M. Okay, so let me give the definition of molarity. It is defined as number of moles of solute, present in 1 liter of solution, is known as molarity. Okay, and what is the mathematical expression for finding the molarity? Molarity, which is represented by capital N, is given as number of moles of solute, where it is represented by small n, by volume of solution, which is measured in liters. Okay, and even this can be written as weight of solute by gram molecular weight of solute into 1000 by volume of solution measured in milliliters. Okay, or one more formula can be taken, that is molarity is equal to number of millimoles of solute, by volume of solution measured in milliliters. Right, we can take all these three definitions to find out the molarity. Okay, and what is the unit used to measure the molarity here? Unit of molarity is moles per liter. Or it can be also be written as molar. Okay, alright. And do it have any effect of temperature on this concentration term? Yes, molarity gets affected with the change in temperature. With the change in temperature. And even in this formula we can see volume term is there, where this volume term gets changes with the change in temperature. When this denominator value gets changes with the change in temperature, even the total term will be getting changed and molarity will be getting changes. Okay, right. And here you can see here molarity is mostly used concentration term among all the chemical methods of measuring concentration. Okay, and here even though molarity gets changes with the change in temperature, it is mostly widely used. Okay, right. And if we come to see, even we are having some applications which are related to the molarity. Okay, we will discuss about their applications in the later part after completion of the sub headings of remaining other concentration terms and even their basic definitions. Okay, right. So let me go with the next concentration term. What is the next concentration term? The next concentration term is the molality. The next concentration term is the molality. Molality. So here molality is represented with what sign? Molality is represented with the small n. And what is the definition of a molality? Molality is defined as number of moles of solute present in 1 kg of solid, or 1000 grams of solvent. 1000 grams of solvent is known as molarity. Okay. And what is the mathematical expression for measuring the molarity? So molarity is given by the formula weight of solute by gram molecular weight of solute into 1000 by weight of solvent measured in grams. Okay, this is a mathematical expression. And if you want to find out the here, if you want to know the units, unit of molarity. What is the unit of molarity? Unit of molarity is moles per kg, or also called as molar. Okay, and do this gets affected with the temperature? Do this concentration term gets affected with the temperature? Molarity does not gets affected. Does not get affected with the what temperature? Why it does not get affected with the temperature? Reason is here in this formula you can see clearly there is no volume term. Okay, volume term is not there. Weight of solute and weight of solvent is given, where weight of the solute and weight of the solvent will not get changes with the change in temperature. Okay, right. And if you come to see, some important Greek prefixes will be added to molarity, molality, and even for normality. Like for example, if you see decamolar or decamolar means what? Deca means 10 molar. Okay, similarly decimolar means it is equal to 0.1 molar. Okay, centimolar means what? Centi means nothing but 10 power minus 2 molar. Okay, and the semimolar means nothing but that is 0.5 molar. Okay, like this the same Greek prefixes like deca, deci, centi, semi, even this can be applied for molarity and also for the normality terms also. Okay, so In a question, generally we used to come across these words where you have to convert them from decamolar to as to this as 10 m, deci means 0.1 m, centi means 10 power minus 2, that is 0.01, and semi-molar means as 0.5. Okay, right. So let us go with the next concentration term after the molarity. The next concentration term is a very important one, that is the normality. What is mean by normality? What is mean by normality? Let us discuss here. So normality is defined as normality is represented with the what sign? Normality is represented with the capital N. And here the definition of normality is given as number of gram equivalence, number of gram equivalence of solute, present in 1 liter, of solution, is known as, present in 1 liter of solution is known as normality. So I think you are going to listen this number of gram equivalence of solute, which is a new term to you. Okay, so we will discuss in detail later. Here, what is the mathematical expression to find out the normality? Is it is given as number of gram equivalence of solute, by volume of solution measured in liters. Okay, the same thing also it is written as number of gram equivalence of solute can be written as weight of solute by gram equivalent weight, which is denoted as GEW of solute. Okay, this weight of solute by gram equivalent weight of solute is called as gram equivalence into 1000 by volume of solution measured in milliliters. Okay, even the normality can be written like this, and normality is represented with the what sign? Capital N. Okay, and here normality formula can also be written as, it is written as number of milligram equivalence, of what? Number of milligram equivalence of solute, by volume of solution which is measured in milliliters, also gives us normality. Okay, so